5-7 Enrichment Worksheet. This is a representation of the drawing that was given to you on your worksheet. Billy and Derek are designing a flag for their treehouse fort. The diagram below shows the design of their flag. I didn't have a blue note card, so I used this orange one, but this is the blue area, supposedly. And then the green area, I did have a green note card. And then the yellow area, and then this teeny tiny one in the middle that was supposed to be red, I had a pink note, sticky note. What I didn't label on here are the sides. This side is X, this side is X, and this side also is X. They are simply labeled by a variable. The height, of my, there we go, the height of the triangle is 8. And since they didn't give us any measurement, we call these units. So this width is 25 units, and this is 2x plus 5 units. So number 1 is write expressions to represent the areas of the blue, green, yellow, and red sections. So when we just look at this area that says blue, and we know that the area formula is length times width for a rectangle. We can take 25 times the quantity 2x plus 5. But remember, that's going to include everything within the boundaries of this particular blue area of their flag. And they want us to just figure out what the area is for what is showing. So we want to keep that in mind and relate it to our pool problem as we go along. But first, what we're going to do is we're just going to write down the areas as if the other areas are not stacked up on top of them. So when we use the distributive property for our blue area, we would get 50x plus 125. And when we do the same thing for the green area, again, we're going to use the area of the rectangle equal to length times width. So we're going to have 19 times 2x, or 2x times 19. And that's going to give us 38x. We do the same thing for the yellow. That's going to give us 2x minus 5 times 13. And when I distribute that, I'm going to get 26x and minus 65. And when I look at my red or pink triangle, I have to use a different formula for triangles, and that is 1/2 times base times height. Because half of a rectangle, if I was splitting these in half, I can see that half of my now orange rectangle does make a triangle. So basically you take you take a rectangle and split it in half and you can get a triangle. But instead of calling it length and width, we're now calling it base times height. So that's why we needed the height of this triangle. So that's going to be 1/2 times the base is x and the height is 8. And when we multiply all that together, because multiplication is commutative, I can take 1/2 of 8 first. And 1/2 of 8 is 4. And then I'm just going to multiply it by the x. So these are my areas as if they were, if I was considering all the space underneath each of these. So what I mean by that is with my note card that is orange that represents the blue, if I were to look at that using the area that I have written down right now, it would be incorporating all of this. When really I want to just talk about this area that I can see. So now that I have these written down this way, I can say, well, you know what? The area of this space is really this area minus all of this. And actually, all of that is just the green. These are just piled on top of that. So if I can get rid of the green, I'm also, in effect, taking away all of those others. So if I could get rid of the green, I would just be left with this. So what I want to do is I want to subtract out, for this answer actually to be accurate, I want to subtract out the area of the green, because if I subtract out the area of the green, that's also going to be taking out these others. So I'm going to come up here and I'm going to subtract 38x. If I have 50x and I subtract 38x from that, I'm going to get 12x, and then my constant is 125. I don't have anything to, I don't have another constant to change that at all. So actually the area of the blue, instead of being 50x plus 125, is 12x plus 125. So this is my area for my blue. Now for the green area, again, if I want to look at the area of my green, so I'm going to move that out of the way, I'm going to just be doing the same thing that I did for finding the area of my blue. I'm just going to be subtracting out this area of my yellow. So when I do that, area of my green is 38x, and I look down here and I want to subtract from that 26x minus 65. Well, remember this is really a -1. So that's going to change the sign on everything inside of here. So -1 times positive 26, that's going to become a -26. And a -1 times a -65 plus a negative is going to give me a positive 65. So this ends up being an addition problem, because this was a -1, and so I am going to be adding a -26x to a positive 38x. And when I do that, I'm going to get 12x and I don't have another constant out here, so I'm going to end up having a positive 65. So that's actually the area that I have for my green. Now for my yellow, I'm going to take away my green. I'm just going to look at my yellow. The area that's going to end up being just yellow is everything, but I have to subtract out the little bit that's going to be the triangle. So I have 26x minus 65, and from that I have to subtract out my triangle, and my triangle is 4x. So 26x minus 65 is the yellow, but then I'm going to come in and I'm going to subtract out the 4x. So when I subtract 4x from 26x minus 65, I'm going to get 22x minus 65. And then for my triangle, I don't have anything left to subtract out. So my triangle is simply 4x. The area for my triangle is simply 4x. So those are the answers to number 1.